Welcome back to yet another episode of Blackboard Math. Today we're proving Heron's formula, which is right here. So Heron's formula tells us the area of a triangle ABC, given side lengths of A, B, and C, is given by the square root of the product of the semi-perimeter with the difference of the semi-perimeter on the first side, second side, and third side. So how do we go about proving this formula? Well, it really starts from the Incircle formula, right? So let's say you're given a triangle and it has side lengths of A, B, and C. I'm gonna say that this first side over here has length A, this second side here has length B, and this third side right here has a length of C. With that being said, if I go ahead and construct the angle bisectors of each side, well, all of these angle bisectors are going to be concurrent at some point, and that point should be, if I drew it to scale, it would be the center of my incircle, or my incenter, if you want to call it that. So with that being said, let us denote the center of my incircle as this point, this arbitrary point, and let's draw some tangent lines to each of our sides. So here's my first altitude drawn from the center of my incircle. Here's my second altitude, and finally here's my third altitude. And all of these altitudes are perpendicular to their respective base. With those altitudes in place, now I can draw some auxiliary lines from the center of my incircle to each of the three vertices of my triangle. So now you can see how those lines are really taking shape. Okay, so here it is, and I don't want to make it seem like I'm randomly drawing some lines, so let me go ahead and mark that off. So here's my incircle, and here's one of the auxiliary lines from the center of my incircle to one of the vertices of my triangle. Okay, so now what are we gonna do? Well, we're gonna go ahead and say that this is the radius, small r, of my incircle, and so now we can find the area of the whole thing, of the whole triangle. So the area of the whole triangle, which we can denote as square brackets area of triangle ABC, is going to be what? Well, it's going to be the sum of the area of these three triangles, right? So it's going to be half my base, so the base over here is B, times my height, which is R, plus half of my base here, which is C, times my height, which is what? What is my height for this triangle? Well, once again, it's going to be R. So that's going to be my height, R. Hopefully you can see that. And finally, my last triangle has an area of half base, which is A, and my height, which is once again R. So now I can go ahead and just factor out my half R's and check out what I get. So I'm going to go ahead and factor out these half R's right here. So hopefully you can see that. I'm going to have half of R times A plus B plus C. So now what we're going to do is go ahead and take half of A plus B plus C. And what is that? Well, hopefully you know what half of the perimeter is. Well, it's just the semi-perimeter. And so what's this going to give us? That's going to give us the semi-perimeter formula, or A equals RS. Area equals RS. And so we can use this formula, as a matter of fact, to prove the area of an equilateral triangle, which we got right here. Alright folks, that's how you derive the A equals RS formula. Thanks for watching, and we'll check you out next time in Blackboard Math.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/BarryScienceLab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.